Okay, so today's lesson is yet another day of factoring, and actually today probably is there is the most important day of factoring because we're going to factor something called simple. Phones away, please, everyone. Simple trinomial. Simple trinomial factoring. Okay, so the first thing we have to, identify or to explain is what does this word mean, trinomial, and also why are we calling it simple? So my first question is, what makes a quadratic trinomial? What does tri mean, everyone? Three. Tri means three, like triangle, okay? Or, for example, but what does it say? Triangle, okay? So what makes a quadratic a trinomial? It will have three things in it. Okay, everyone? It has three things. By the way, no one calls it things. I just call it things because I like to use simple words. But the official word is terms. Terms. Things. Terms in it. Okay? It has three terms in it. Okay? So what are examples of trinomial? Anything you can come up with that looks like a quadratic and it has three things in it is a trinomial. Remember all the examples I used to do on Desmos. So for example, y equals, give me three numbers. Because you have to give me a number with the x squared and a number with the x and a number with the 3. So you have to say 3x squared and then maybe minus 12x's plus 5. Okay, what's another example? You can use any numbers you want. I'm going to use decimals this time. So 0.75 x squared. Or you know what? Let's not use x all the time. Let's use a different symbol, like maybe a squared minus 16.3 a's. My last number has to be just a number. So positive, plus 1.9. How about another example? Maybe instead of y, maybe we can call it h equals. I'm going to use fractions now. What's a good fraction? 3/7, I guess. B squared minus. Actually, I'm going to make this a minus. Everyone, I'm going to make this minus 3/7. Positive 6/7. No, we use 7. 6/13. B minus 2/3. And so on. Okay? As long as you have three things. Again, as long as you have a quadratic term, like something before the x squared, that is not a 0, and you have three things, all of them are legit. Okay? Whether you use fractions or numbers or decimals or you mix and match, up to you. Our numbers, yep. Okay, how about a binomial? Just incomplete numbers, yep. How about binomial? Tri means 3, binomial means 2. So what are examples of, what makes a quadratic a binomial? It has two things in it. It has, did I say 2 in words or 3? Okay, so it has two things. Ben, is there a reason you're not copying? So what are examples of binomials? Two numbers. However, you still have to have a what? An x squared. Because you might say, oh, Mr. Ramadan, could this be a binomial? Everyone, just look up at the screen.
Why do we still need an x squared?
Because then it would not be a curve. It needs to be a curve. Everyone, what if you say this? Look, everyone, eyes on the screen. Can I just delete this? Would this be a binomial? It would be, but this would not be a quadratic. This is not a quadratic because you don't have an x squared. You see? you still need the first what? You still need the first x squared. So I'm going to put it back in. For example, can you say, oh, I'm going to delete this one? No, you can't. This is not the binomials we're talking about. What you can delete is this one, or this one, or even this one. But you have got to have two things, one of which has to be a what? A quadratic or a square power. Good, nice. So I'm going to put them back in here. Bless you. So I'm going to repeat the exact same ones, but I'm going to choose which one of these two to take out. All right. So y equals 3x squared. I'm going to take this one out. So it's going to be plus 5. Okay, how about this one? I'm still going to keep the 0.75 a squared. But this time, instead of taking this one out, I'm going to take this one. So minus 16.38. Okay, how about this one? I think I'm going to take out this fraction with the b. All right, so negative 3 over 7 b squared. Take this out, which means only minus 2/3, comma, and so on. Nice. So today, which ones of those are we going to learn how to factor? The tri or the bi? Today, we only focus on the trinomial. Today, we only focus on the trinomials. Tomorrow, we will do binomials, and we'll do also some cases where things could be mixed as well.
Why is the
Mhm. Oh, you mean here?
no?
Oh,
Well, yes.
I just chose to make it negative. Again, I'm showing you that you have 100% freedom in choosing how the numbers look like, as long as you have a square in the first variable that you see. That's all. All numbers are okay. Okay. So today we learn how to factor a simple trinomial. Okay. What makes a trinomial simple? Everyone, what makes a trinomial simple? One thing. The first number in it has to be a 1. If you see a quadratic with 3 terms where the first number before the x squared is a solid 1, we call that a simple trinomial. If the number is anything other than 1, even if it's just a negative 1 as well, you can't call it simple. 1 is the only number that makes it a simple trinomial. So what makes a trinomial simple? The number, the number before x squared, or a squared or b squared, but I'm just going to keep it to x squared because it is the most common way to say it, is 1. Anything other than 1 does not make it a simple trinomial. Okay? So you might ask, oh, so what would you call it then? Well, can someone tell me what's the opposite of the word simple? Yeah, that's actually the name. Simple trinomial if it starts with 1. Complex trinomial if it starts with anything else, which means this would be, sorry, those are binomials, my bad. If we go up to here, does this start with a 1? No, so it's a complex trinomial. Complex, complex. It needs to be a 1 for it to be simple. Our job today is only to take care of the simple case. All right. So what examples are there of simple trinomials? Anything you want, as long as you make your first number what? All right. So here are some examples. Y equals 1x squared. By the way, if you have 1, do you have to write it? No. 1 x squared is the only case where you can just write x squared. So 1x squared minus 3x plus 7. Y equals 1x squared plus 16x minus 5, and so on. All right. Okay, so today is the lesson for factoring those simple trinomials. How do you factor it? Okay, here are a couple of examples. Okay, okay, I need to invent a simple trinomial. Give me a minute. Well, obviously, I have to start with x squared. So I need to invent the other two numbers. All right, hold on.
You haven't invented the number math. Those numbers have been around for the same.
You're right.
Right.
There we go. Everyone, go ahead, write that down. Come on. Oops, my bad. Just write it and stop. Pencils down. By the way, the process is so simple and it could sink in if you just give it some time. Can someone tell me what's the last number there? 24. Okay, pencils down. Give me two numbers that multiply to 24. So give me two, raise your hand, don't just shout them out. Give me two numbers that if you multiply together, they give you 24. Abu Bakr, give me one choice. By the way, there's always, not always, most likely there are so many choices. Okay, Abu Bakr, give me one choice. I need two numbers. I need the pair. That's the whole idea. I need the pair in your head. What times what gives me 24? 6 times 4. How many people agree? Yes. Who would like to give me another option, another duo of numbers, another double number? Ragad. 6 times 4. 2 times 12. Thailand. 8 times 3. One choice left. 1 times 24. Can you think?
I was going to say.
But one, by the way, 1 times 24 is always the what? The easiest one. Okay,
One times the
number itself. So now we're going to start what? Writing those numbers or those pairs down. Everyone, I want you to always write it this way because I want to teach you organization in your solution. Okay, everyone, I want you to write 24 here. Let me actually zoom out so you can see how much space we're
They're
going to.
like our parents when they keep our bedrooms organized. That's your putting on.
Well, my experience so far for 25 years of helping people with math is people screw up because they don't have organized notes. Well, let alone if they have. Look, I've been helping people since I was myself in grade 10. Yes. Yeah, yeah. When you have me, you have no idea how much experience you're getting. And good experience, because basically I was helping as a student, because I know exactly what you go through. And my experience honestly is many people screw up math just because they don't keep good notes. That's it. It's as easy as that. Because I struggled when I didn't keep good notes, and I became a good teacher when I kept good notes. So if it works for me, I don't think it should not work for you. Okay, 1 and 24. Please leave some space here because I don't want you to write 124. Okay, what do you think our next pair should be if we want to write it in an organized way? Come on. Remember, Ragad gave us 1. Abu Bakr gave us 1. Caleb gave us 1, which I just did. And Colin gave us 1. Which one do you think should be the next pair? Come on, people, to be organized. Oh, you had your hand. Yes. Why did you go with 2 and 12? Thank you. If this number goes up, this number has, sorry, if this number increases, this number has to what? Because it's always a balancing game, right? Okay, so Katrina said 2, 2 and 12. Sorry, that's a bad one. 2 and 12. Keep going. What should be our next pair? By the way, if you do it this way, you are guaranteed that you are not going to miss a single pair in the list. 3 and 8, because 3 and 6 gives you 18. So 3 and 8. Okay, almost there. One more. So, if you want to write it properly, we have to write what? 4 and 6. By the way, if you write 6 and 4, it's still the same. Do you see how organized this is? 1, 2, 3, 4. It basically, these numbers increase which means these numbers decrease. By the way, I'll give you also another hint to know if you have more numbers. Sorry, like if you when do you know that your list is about to be done? What are my first two numbers? 1 and what? Everyone, are they close apart or sorry, close or far apart? Okay, so everyone, imagine my hands 1 and 24. What's my next pair? 2 and 12. What's my next pair? 3 and 8. And my last pair. What's happening to the distance between the numbers as the list goes down? Do the numbers get further apart or closer together? Closer, no, closer together. Now, if this is about to increase, what's the next number on the list? Do you think 24 divides 5? No way. Why not? What are the only kinds of numbers that divide 5? Any number dividing 5 has to end in one of two ways only. 5 or is it 10? Count in fives in your head. 5, 10, 15, 20, 25. You always alternate between what? Ending in 0, ending in 5. Ending in 0, ending in 5. So are we done with the list? No. I just said the 5 doesn't work. So that means what? 4 and 6 are as close together as they can get. Okay, that's my first step. Second step, can someone tell me now what's the middle number in the trinomial? The middle number. No, the middle. In the trinomial, what's the number in the middle of it? 10. Okay, I want you now to look at each pair, and tell me which pair will give you a 10 if you either add them or subtract them. So, what's 1 plus 24? Not that. Okay, what's 24 minus 1? Exactly. And the process is, those two will never work. So I want you to do this now. Cross them out. How about 2 and 12? Nope. If you add them, you get 14. If you subtract them, you get what? Whoa. Hold on. So that means what? Bless you. How about 3 and 8? 11 or 5? Bad choice. How about 4 and 6? Okay. By the way, you might think, oh crap. So two pairs are gonna work? No. It's tricky. It looks like we're gonna have two possible solutions. No. I'm gonna show you how to decide which one of these is the real one that's gonna work for you. So what we're gonna do now is this, everyone. Have we already circled the pairs we need? Yes, we did. Okay. By the way, what does factoring mean? Do you eliminate brackets or do you try to create them? You try to create brackets. So everyone, here's what we're gonna do. We're gonna put bracket, 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 bracket. Okay? I'm gonna squeeze this a little. Sorry, squeeze this a little bit. Yes. I'm gonna move this guy here. Okay. What do you put in the beginning of each bracket? You put this. You put an X and an X. Okay? Okay. What do you do next? You put the 2 and the 12. You put the 2 and the 12. Okay. What do you think I'm still missing between the X and the 2 and between the X and the 12? Either a what? Either a plus or? Okay, everyone, pencils down. I'm going to show you how to actually do this in your head. Let's do plus plus. Let's do plus plus. Okay, what's X times X? X squared, okay. What's X times 12? 12 X's. What's 2 times X? Okay, what's 12X and 2X? Come on, what's 12X and 2X? Like adding, what's 12 and 2? No, 12 and 2. 14. Is that a 14? Okay, that's a 10. Okay, so two pluses are not gonna work. Okay, let me try to make this what? what? Okay, and let's repeat. Again, what's x times x? Okay. What's x times 12? 12x. What's negative 2 times x? Negative 2x. What's 12x minus 2x? Come on. 12x minus 2x, like 12 minus 2. It's okay. Okay, it's 10. What's negative 2 times 12? Negative 2 times 12. Nope. What's 2 times 12, but the 2 is negative? I have no idea why many of you just look at me and guess answers when you always have cell phones in your hands and you can just plug it in. Obviously, I would love for you to be good with mental math. It's sadly not an experienced skill with your generation at all. And I don't blame you. You've been born into cell phone generation. You've never had to practice, which is really bad. But instead of just looking at me and throwing numbers, plug it in. That's all. The question is, what's negative 2 times 12? Kylan? 24 with what sign? Crap. It's not working yet. All right, what do? I make this plus again and make this a what? Okay, I'm trying to find something that spits this one out again. Almost. What's negative 12 plus 2? Negative 12 plus 2. With an, God damn it. I need a plus in the middle. No. I am showing you that you're right, but I'm showing you that even when you think two pairs are going to work, no way. It seems like the 2 12 are going to work, but it's never going to do it. Why? Because you are never going to find the what? The magic pair of signs that will make it work, ever. Is this going to work? It's going to give me a positive 24, but when you add minus 2 and minus 12, what do you get? Minus 2 and minus 12. Losing $2 and losing $12 is losing what? 40. This is never going to work. So everyone, I want you to cross it out. So what's the only other pair we're going to find or we're going to choose? 4 and 6. I heard Abu Bakr say something. Both must be what? Must be positive. Because that's the only case that you're going to produce once you expand. That's the only case you're going to produce a positive 10 and a what? Positive 24. Do you always have to show me your checking step? Okay. Some teachers might require it. Some teachers might say, after you show me your factoring, prove to me that your factoring is correct. Then what do you have to show them? You have to expand this back again and show them that this still gives you what? Still gives you that. I guarantee you, I promise you, I will never ask you to do that. But do I encourage you to do it? Yes. Not on paper. Just do it mentally. Abu Bakr, what's x times x? X squared. Got it. What's x times 6? Plus 4x. Plus 4 times plus 6. Done. What's another way to prove that those two things are the same? What do you use? A website. Desmos. You sketch this guy and you sketch this one. Perfect lineup. Okay. I want to give another example. Y equals. I still have to start with what? You always have to start with 1x squared, or for convenience, just x squared. Hold on. I want to give you a longer list now. By the way, don't worry. I'm not going to give you a list where you have to go like through 20 pairs. No. That doesn't test math. That just makes your life harder for absolutely no reason. So let's go with. Hold on. Yes. Yes. All right. What do we start with? Which number do we always look at first? Kylan? No, okay. You know what? Before I get to Colin, I want Colin to do this. I love that you said what? 1. You always have to check that you have what at the beginning. Otherwise, you don't call it what? You don't, which means, do you apply what we learned today? No. If it's not simple, you cannot do what we're doing today. So you always have to check what? The 1. And then you start with these steps. Colin, which number do I look for? Sorry, look at after checking that I start with 1? No. I mean, which number of those numbers do I start my solution with? The 19 or the 60? Always start looking at the last number. Okay, everyone. 60. What's my first pair? Come on. 1 times 60. Do you think 60 divides 2? Basically, I'm asking a backward question. Is there such a thing as 2 times something gives you 60? Perfect. Do you think 3 is going to work? Come on, it's 6, which is like 60. You're right. 3 and 20. Do you think 4 works? By the way, if you ever want to see if it works, just divide it. If it gives you a decimal, it does not work. Does anyone know 4 times what gives you 60? 4 times 15. How do I know that? I'll divide 60 by 4. I'll get the other part of the pair. 4 and 15. Do you think 5 is going to work? I just told you the trick to the 5s. Bless you. 5 is? You remind me of my dad sneeze. He wakes me up, basically. 5 times? Do you think 6 is going to work? Yeah. 6 times 10. Everyone, do you see how the numbers are getting what? Closer together. Do you think 7 is going to work? We can try. Look, everyone. 60 divided by 7. Whoa! Out of the window, right there. Do you think 8 is going to work? No, it's going to give you 7.5. Do you think 9 is going to work? Do you think we're done the list? Yes, we are. Perfect. Actually, we are. Oh, I did it. Remember, flipping the list does not give you any more what? Any more numbers. Okay, done the numbers. Yes. Yep. I'll zoom out. Yep. What number now do I look at in the original equation? 60. I'm done with the 60. What number do I look at now? 19. 19. What's 60 plus 1? What's 60 minus 1? No. You know what? Way too big of the number difference to actually work. Cross it out. That is a bad pair. Do you think 30 and 2 is going to work? No, still big. 20 and 3, still big. But things are getting what? Things. 30 and 2 gives you what? Either 32 or 28. Bless you. What's 20 and 3? Gives you 17 or 23. Bless you. And you have to do both just to check. Do you think 15 and 4 is going to work? Okay. So everyone, 15 and 4 is definitely a what? Is definitely a candidate. Bless you. You must have bad allergies, man. That was me 2 days ago when I mowed the lawn. Yeah. Does anyone know Reactin or Claritin? Like the allergy medication? Oh, I live on it for 2 days once the seasons change. What's up? Let me just finish this one. 12 and 5, do you think it's going to work? Come on, 12 and 5. Kylan, what do you think? No. 12 plus 5 is 17. 12 minus 5 is 7. That's neither 19. How about 6 and 10? All right. What's my pair? 4 and 15. Let's do it. pair, x, x, or 15. All right, the signs. Do you think two pluses could work? Why not? How can you have all pluses and expect to create a negative when you expand? Sorry, that doesn't happen. How about if someone says this? Kylan, do you think this is going to work? Sorry. Okay, Kylan's saying, I think so. Well, let's what? Let's expand and see. X times x, who needs to do that? It's always got to be x squared. What's x times minus 15? X times minus 15. Minus 15 x's. What's plus 4 times x? Plus 4 x's. What's negative 15 plus 4? Losing $15 and gaining $4 back. Negative what? That's not what I want. No. I said negative 15 plus 4. Do you think this is going to work? No. Still as bad as that one. So what's the only case that's going to work? Both what? Thank you. X times x is x squared. X times minus 15 with minus 4x. And minus times a minus gives you what? Got it. That is all. That's all we need to know for simple trinomial factoring. Done. That's it. So let's take up a few of the ones on the second page. By the way, all of them are the same idea. You just have to do the trick sometimes of plus and minus. Okay? Yes. Oh, both were minus. My bad. X minus 4, x minus 15. Okay. Sebastian, which one do you want to do? Everyone, Sebastian, I'm going to just ask one of each to choose one. Go. First? All right. Okay, everyone, we're going to do this. Is this a simple trinomial? Actually, are all of them simple trinomials? Okay, what's the number here? 1, 1, 1. Okay, so far, everything is good. Okay. So far, so good. You have to check that out first. Is this entire page a simple trinomial page? Perfect. Okay, so our techniques today work. Sebastian, which number of those three numbers, well, two numbers really, because the one is there, which number of those two first do you look at? The 8 or the 7? The 7. You always look at the number by itself first. 7. 7 is so easy. Only two numbers multiply to 7. 1 and done. Well, if you don't have any other choice, this must be the one that works. Okay. So, sorry. If I do this, am I correct? No, I'm not. Exactly. Everyone. By the way, I still make these mistakes sometimes because I'm so used to X just as much as you are. Please make sure you always use the symbols that the question uses. So B's, a single B here and a single B here. Because when they multiply, that's what makes B squared. And a 1 here and a 7 here. What's the only sign choice? How are you going to create two pluses if you don't have all pluses inside? Exactly. So positive and positive. That's it. By the way, those questions, if I ever give them to you, depending on the size of the list and the signs, never worth more than 2 marks. If it's super simple like that, it's worth 1 mark. If it's a bit more complicated, like a longer list with minus and pluses, tops 2. That's it. Okay, let's do, everyone, I want to do this one. What number do I look at first? The 12. Thank you. So everyone, Here's the 12. What's my first pair? Pair. 1 and, remember, you always have to give me two numbers. 1 and 12. What else? Let me just finish this one. 2 and, no, 2 and 2 and 6. My last pair, 3 and 4. By the way, can you ever get closer than 3 or 4? No, they are one number apart. We're done. Which one of those pairs give you a 4? Hmm. Sorry, say again. Yeah, 12 and 1 are way too big. 12 plus 1 is 13. 12 minus 1 is 11. 4 and 3 are not quite right because 4 plus 3 is 7 and 4 minus 3 is 1. So the only pair that must work is what? 6 and 2. It was 2 and 6. All right, so go ahead, everyone. Circle 2 and 6. Okay, so here is my bracket. Bracket, bracket, bracket. X, sorry, not X. What symbol? N, N. 2 and 6. Okay, signs. Could both of them be plus? No way. Because if both of them are plus, then everything on top should, so like at the beginning, should be plus. Could both of them be minus? Why not? Everyone, what's the easy, quick proof that you cannot have minus in both? Because if you have a minus here and a minus here, and you multiply -2 by -6, what's negative times a negative? Sorry, I don't have that. Which means one has to be positive, one has to be negative. One has to be positive, one has to be negative. So you're saying the 6 has to be positive. You're right. Can you tell me the quick and easy way to always know without trying which one definitely is that? Everyone, the bigger number is the what? Is this sign. Because it has to be the one that wins. The bigger number has to be this sign. Done. So it's positive and negative. Check. It's gonna work. N times n is n squared. N times 6 positive is positive 6 n's. Minus 2 n's, boom, positive 4 n's. Done. Always put the sign in the middle with the bigger number of the two. You will never make a mistake that way. Okay, let's do another number with another one, sorry, with mixed signs as well. Which one should we do? Yes. Yes. Let's see. Which one do I want to do? Okay. Everyone, let's do this one. 90. All right, let's do the list for 90. What's the first one? Oh, sorry, first pair. 1 and 90. Do you think 90 divides 2? Basically, I'm asking you, is 90 an even or an odd number? All numbers ending in 0 are even. 10, 20, 30, 40, 50, 60. So this divides 2. 2 times what gives you 90? No, 45. Oh, did you say 45? Oh, yeah, 45. Do you think 90 divides 3? Of course. 9 divides 3, 90 divides 3. 3 30s. Yep. Do you think it divides 4? You can try. 90 divided by 4. Oh, decimal. Do you think it divides 5? Do you think it divides 5? Of course it does. It ends in a 0. 5 times 18, by the way. Do you think it divides 6? It does. 6 times 15. 7 doesn't work. 8 doesn't work. 9 works. Okay. Which one of those, by the way, can someone tell me what's the number here? It doesn't appear, but what is it? 1. Everyone, I want you to add 1 here. Please go ahead and add 1 here. Everyone, add 1 right before the M. Can you tell me which one of those paired numbers is going to have a relation of 1 if you subtract or if you add? Which one? 9 and 10. All the other numbers, if you add them, they give you big numbers. And all the other numbers, if you subtract them, they don't give you 1. 90 minus 1 is 89. 45 minus 2 is 43. 30 minus 3 is 27. 18 minus 5 is 13. 50 minus 6 is 7. No, 50 minus 6 is 9. 10 minus 9, perfect 1. I got it. Okay, so Abu Bakr already clued in into the signs, but that's 9. I want a 1. Yes. So M, 9, and 10. Now, which one is the bigger number? 9 or 10? What sign do I have in the middle? Boom. Just put the sign in the middle with the bigger number. That's how things win. Full marks. Never fails this way. Put the middle sign with the bigger number. Okay, one more and we're done for the day. Oh my God. Everyone, I want to do this one. I know it's an easy case with pluses, but you'll see why I want to do it. Can someone tell me what number do I look at first? 64. 64. Okay, I'll spare you the first pair. 1 times 64. Do you think 2 works? Yeah, 64 is an even number. All even numbers are divisible by 2. Hold on. I want to show you something. Do you think 3 works? By the way, does anyone remember? I said this trick a few times before. Does anyone remember the trick to know, without even using a calculator, if a number even divides 3 or not? Come on, people. This is important. This is really needed sometimes. How do you know, without using your calculator, if there's even hope of a number dividing 3? Actually, it depends, because sometimes the last number, if it's a multiple of 3, or if it's not, it still works. You have to check all the numbers, but in what way? Again, you add the digits. What's 6 plus 4? Come on, no tricks, I swear. 10. Does 10 divide 3? No, done. That's it. If the addition of the digits divides 3, it works. If it doesn't work. Done. And I'll prove it to you. 64 does not divide 3. It's an infinite decimal. It does divide 4. So my next number is 4 times 6. Sorry, my next pair is 4 times 16. 5 doesn't work. 6 doesn't work. 7? Ragad, you said it. 8. 8 times what? Yes, 8 times 8. Because 64 is one of those perfect squares. 8 times 8. Okay. What number am I trying to create? 16. Which one of the, bless you. Which one of those is only can create 16? Hold on, say again. 8 plus. So the numbers could be the same. Yes, they could. That's why I want to do this example. Sometimes the numbers you need are the last ones on the list, and they are the same. Okay. Can you tell me what the signs are? You have all positives to create. You have to use all positives in. Do you think there's an easier way to write this? Technically, when you multiply something by itself, what do you call that? When you multiply 5 by 5, or 6 by 6, or x by x, you call that what? Squaring. If you leave that like that, I have to take half a mark off, because that's not the easiest way to write this. What's the easiest way to write this? You write a single bracket. Oh, you can't do anything but that. Because whenever you say 3 times 3, You can just say what? Oh, no. That's if you expand it. We don't want to expand it. We want to keep it factored. We want to keep the bracket. Done. No, it's okay. That's it. Done. That is the last thing. But when can you only do this trick? When the two brackets are the what? Are the exact same. We could not have done it here. I can't do it here. I can't say, oh, this is equal to n minus 2 squared. What? Why? Well, someone might say, no, I'm going to call it n plus 6 squared. You can't do it either way because those are not the same. So you have to leave them what? Next to each other but separate. Okay, so always remember you have to combine them into a square bracket like this only if they are the same. And you have to. If you don't do it, I am sorry, but I have to take half a mark off. Yes, Caleb? No, 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 no. Everyone, because the whole thing is squaring itself, the exponent is outside. And again, I'm going to prove it to you by Desmos. Here we are, Desmos. I'm going to sketch the original one. What's the original one? Y equals hmm? B. Oh, B. Whoa. Did I use X or B? Ah, see? I swear, I did not mean to trick you. I actually made a mistake. My bad. Everyone, that's how you lose marks in these. You should not have used X. You should have used B. Honest mistake. I am so. No. And you know what? Even but am I invincible? Am I completely absolved from making mistakes? Of course not. Please have some confidence in yourself and correct me, even if you shaky on it. That's fine. So let's go here. Even Mr. Shivers make mistakes. That doesn't mean we don't understand. That means we're just quick. We want to be done as much as you want it to be done. Plus what? 16 B's plus what? 64. All right. My factored one was what? X plus 8. And then where's the square? Inside or outside? Sorry. Ready? To the power of. If I click 2, the new curve has to perfectly cover that one. 3, 2, 1, go. Yep, perfect. What would happen if you placed it inside? I'll show you. Everyone? No. It's going to be a curve, but it's not going to perfectly line up with that. Look, everyone. You ready? Here it is. See where it's going to be? Oh, it's here. Sorry, that's not the same. The 2 has to be outside of the bracket. It cannot be inside. Done. And that's today's lesson. And honestly, this is the most important lesson in factoring, how to create two brackets and check that your answers are correct.